Hey guys, welcome back. So today we're still working on the Equus because last time when I parked this vehicle and then went after a day, the battery was dead. So we're are doing some parasitic growth testing. So right now I'm charging the battery. I was testing this and I confirmed there was a draw at 500 milliamps, which is excessive. And then I found it's from our audio unit, right? So actually it's from the audio fuse. So I did voltage shock on every fuse and just gonna show you guys on what I found out and how my process on dealing with parasitic draw. And also we're gonna be featuring my new tool. It's a thermal imager. So we'll be featuring this new guy here. This is very helpful because this is visual, right? We can see which components are turned on, and also as you can see my schematic, this is, as you can see my mouse, this is where our draw is, and as you can see there's 7 components that's using the fuse, right? So instead of pulling every connector for that components and waiting for the current draw to drop, we're gonna use our thermal imager and see if we can pinpoint which components is hot enough causing for that draw. So let's go back to the car and see and show you guys my process on how to prepare the vehicle for parasitic draw testing. So of course, you know that your battery is bad, or not bad, it's low. So as much as possible, you fully charge it. So right now I'm on 86, I think, more or less, fully charged. So I'm just gonna turn that off, and that should be fine. And now we're gonna prepare the vehicle. So make sure your trunk is closed, right? Because so that we can access the negative cable of the battery. Next will be our doors. Make sure that's locked. Okay, that's locked. And since this Equus has a door switch, we can remove this. Oh, that's tight. So I'm just gonna remove this switch. So you don't have to remove the connector because as per the diagram, this switch itself is grounded to the body. That's where it gets the ground circuit. So as you can see there, if I touches this Equus logo will light up. Let me see. Let's put the ground there. Okay. What's going on? No light? Where's light? Okay. So we'll just let it hang there. And then we're gonna go to our hood. Why am I opening this? Because on this side of the car, there's a fuse box, right? So we're gonna check the voltage drop on each fuse to see if what fuse is drawing power, right? Of course our hood, so we have to lock this. Just push it, or if you can access the, oh man, okay, that's locked. So if you can access the connector for the hood, that will be great, right? Okay. Same thing on our driver's side. Let's remove this switch here. And also your lock actuator. Okay, that's locked. Because we got our fuse box there too. So now we're gonna remove our key, and the whole system or the whole car should be locked. Right? One way to know that is when the lock signal will, or the lights will lock on. See that? And there's a beep, so meaning the whole system is locked now. So let's unlock it first. Now since our preparation is okay now, so since our preparation is good now, one other way to measure the current on the draw is by using a current clamp. Or if you don't have a current clamp, so usually this is what I use, right? And you can connect this to the DVOM, right, to see the conversion and the voltage to amp, right? So now we're just using a 20 amp. That's in every 100 millivolts there's 1 amp. So I'm just gonna turn that on. But since I have some scope, right, which is better because it's more visually, we can see the drop itself, right? So let me just put some meters here, voltage reading. And now I'm just gonna adjust this to 1 volt. Okay, so now I'm just gonna turn this on, and we just have to clamp this. We don't have to remove the negative cable or anything and touch it again to the terminal. We just have to clamp this to around the cable. So I'm just gonna touch that there, and I'm gonna unlock this. As you can see there, it went up. Let me change my time base so that you will see. So if I'm gonna unlock that, it went up, right? Let me adjust this one more. Okay. Okay. One more. Okay. So as you can see there, moves up. So now, next is I'm gonna lock the system, and we're gonna check how much draw will it draw from the battery. So I'm gonna lock the system, put away the smart key fob, not near in the car, because the car will keep looking for the key, right? Especially if it's near around the car. So put away the smart key fob, like maybe 2 meters away or a meter away. So I'm gonna lock this now. Okay, so now we're just looking for the draw, right? How much draw is the the battery right now? So right now, let me move this thing here. Oh. And then we'll wait a few minutes, right, until I think last time when I was checking this, just 10 minutes when everything starts to shut off, right? So right now we're reading right now 68 millivolts, right? So it says there in every millivolt, 100 millivolts, there's gonna be 1 amp. So we just cancel 2 zeros each other. Okay, let me grab a pen. Okay, so in what happened right now is we're measuring it from 100 millivolts from the tool, right? That's equals to 1 amp, right? In 1 amp there's 1000 milliamp, right? So that's 100 millivolts. So now we just cancel 2 zeros here, so we're gonna have a millivolts now here and 10 milliamp. So right now, after maybe 2 minutes guess, we got 306 millivolts right now. It's reading. Can you see it? No, you won't see it. So but just take my word, that's 336 millivolts, right? So right now 36 millivolts, and then we'll times it with 10 milliamp, so that we'll get the value for milliamp. So more or less we got 360 milliamp current draw right now. So we're just gonna wait for a little bit now. All right, maybe we'll give it another 10 minutes and see if it will drop more, right? If not, we're gonna start doing testing on each fuse. That's why we open those doors. Okay, so we're gonna recheck this after a few minutes and see how much draw we have. And we have 400 millivolts, so that's 400 milliamp, so that's too excessive. So next will be, we're gonna go start on the fuse boxes, right? And we do our voltage drop on each fuse, because you can also do removing the fuse, right? Each until you monitor this until what fuse drops. But the problem with that is you're removing fuse and maybe accidentally wake up a module, and you will never know. So we're gonna go to our passenger side first, right, and do our testing, and let's see. Okay, here's my meter. We're gonna put this on the millivolt scale because we're measuring millivolts, right? And as you can see there, our voltages are jumping around if they're not connected. So connect it first, it should reach 0, right? Same thing on our fuses. So what we're gonna do is we're gonna go through each fuses, right? So since I'm holding a camera, we're gonna do a chopstick style. Just probe the top of the fuse, right? So consider 0 millivolts. If you're not touched on the blade itself, let's say I'm moving like that, and this guy is not on the probe, as you can see there, my negative test lead is out, and as you can see there are voltages is jumping around. So you will know that if you're connected or not. So we're gonna go through other fuses. You go each line here, right? So I'm just gonna jump around because we know that it's from our audio unit fuse or audio fuse, alright? So I'm just gonna do like that again. As you can see, 0, right? So I checked this already. There's no voltage drop on each fuse there. So we're gonna go to the driver's side now, and let's see. So we're on the driver's side now. I can just from the cover. So we got our cover here. So we're just gonna go straight onto the audio unit. So it's gonna be audio plus B plus 15 amp where my thumb is. So that's gonna be this guy here. So I'm just gonna go there straight, probe it, but oh my goodness. Okay, so I'm on top there. As you can see there, on top of that fuse, we're reading 3.17 millivolts. So that's our suspected circuit that's drawing the current, right? So now, just to confirm that that's really the circuit, we're gonna pull that fuse. We're gonna go to our scope or the current clamp, and let's monitor again our draw. So I removed that and went and dropped right away, but let's just reset everything again, and we'll lock the vehicle and monitor again. Okay, so I just locked the vehicle. As you can see there, the current went up, so we're just waiting for it to drop. So as of now, it's drawing 340 milliamps, right? We're gonna wait a little bit, and more or less it should drop anytime soon. Okay, so I just saw that drop at the very end, right? So right now everything should have no draw right now, because that's what we're measuring at the negative cable. So now I'm gonna grab our thermal imager, right? I'm gonna put that fuse back on, and let's see. Okay, our thermal imager here. So of course, when using a thermal imager, make sure the car is in the room temp, so that it will really show here which one is the hot spot. So instead of removing each component, that we know where the circuit doing current draw, we're gonna use our thermal imager and pinpoint which component is drawing that current, right? So let me move these guys here. So we're just gonna sit. Okay, so first thing we see, these are front screen, right? That's part of the circuit. The sides, yeah, but it's not bad. I think it's just the light, right? We go to our audio unit. So our audio unit, I'm just positioning my camera. As you can see there, that's glowing red, right? Compared to our front LCD, more or less that's 29 degrees. But our audio unit itself, as you can see there, that's 34. And then what else is part of that one? It's the console here. So as you can see there, nothing much on that one compared to our audio unit itself. So what we're gonna do next is, since we pinpoint the component which one is drawing that current, what we're gonna do is we're gonna remove that audio unit, remove the power connector for that, and let's confirm on our scope or on our amp clamp that it's not drawing anymore current, right? So I'm gonna remove that and see. Okay, so as per the service information, let me just put this into neutral or drive, whatever. We're just gonna remove this cover here. Okay. Oh, that's sticky. Why is it sticky? Next will be, we're gonna remove this center fascia, they call it, right? So. Okay. So I'm just pulling all the connector. Okay. How these connectors come out? Okay, you know what? Okay, there's a pin. Let me grab a pick. Come on. What? Yeah. You know what? I don't know how to remove that. All we just need to do is to remove this audio unit, right? So let's not worry about that small connector. I'm just gonna remove this guy. Oh, where's that screw? Oh. Oh. Come on. Oh, come on. That's stuck. Let me grab a screwdriver. Okay. This bottom part is, I think it's too tight. Come on. It's not even the right one. Oy. That's good. Okay, and then there's 10mm bolt there. I'm gonna remove that. Okay. Now everything is out. Should be able to remove this. Oh wow. I can feel the audio unit is hot, even though we're not using it. So now is I have to remove that connector. Oh man. Now let me remove this stuff here. Okay, that's out. This way. Okay. And there's another one. Okay. Put that aside. How do you unplug this? Guys, you can't see anything there. I'm just unplugging the whole connector here right now. Just stick tightly. It's out. Whew. So it's out. Yeah, I can feel it's hot. Like it's on all the time. It's not supposed to be like that, right? Unless something triggered that to make it on all the time. So now we're gonna go back to the trunk and let's monitor our current draw, right? Make sure there's no draw there. And we can also check our fuse for the audio unit. Make sure there's no voltage drop there. So let me just put this to work. Come on. Okay. I'm just gonna turn this guy on. Okay. Okay. I'm gonna turn on my amp clamp, or the current clamp. Okay. Lock, unlock, lock. Okay, so right now, let me just so right now it's drawing 59 millivolts, or no, 54 millivolts, right? That should drop more. .46 millivolts, so 460 milliamps. I'm just gonna wait. We'll put this paper there. just in case if this guy is still on or something, it's not dropping out, it could be that there's an issue on our harness. Something is powering out the harness. Okay, so I can see right now, as you can see there on the very end, that it dropped right when I was started talking. So let's see what's the voltage on that one. So that's 32 millivolts. It's still high. So we should be around, depends on the module, how many modules equipped on the vehicle. My rule of thumb, or more or less, is at least 15 milliamps, right? Maximum, very maximum is 100 milliamps. It should be okay, but 50 milliamps, okay, that's good. As you can see there, it dropped at the last portion, which is good, right? Don't worry about that spikes, because I think that's when I move this guy here, the connection here and the probe, right? So that's good. I'm gonna just zero that and see. So let's see. So right now we're in 10 millivolts, right? So that's 100 amps, 100 milliamps, so which is not bad. So I hope I showed you a decent enough process on how to tackle a parasitic draw on these vehicles, right? Not only this vehicle Equus, but any other vehicles. So in my process on how I do it, that's how I do it. So I hope you enjoyed that, and we featured the new tool, the thermal imager. I know it's been there for a long time, so I just used that because I read and did some training, and I saw that they keep using the thermal imager. It's not only for current draw testing. You can use it to check your catalytic converter if it's clogged, right? They say you can check also if there's a misfiring cylinder by checking on the exhaust manifold. So I hope you enjoyed that video, guys, and don't forget to like and subscribe. See you next time. Thank you for watching.